Okay, I guess we are ready to start here. I know it's getting late in the afternoon. So let me start here by a short introduction of our new logo, DELL EMC. So it was announced at EMC. From the time we submitted this until now, we changed the logo, we merged with Dell. So actually downstairs you had 3 different booths from the same company, the VMware, the Dell, and the EMC. I know that they are closing the stuff downstairs, so I will be here sometime. If you want some questions asked or something like this, just find me anywhere in the hallway after this. What is this presentation about? Basically our history. So we have a product. I will say now very specific. It's a product, it's not a project. It's a product that we are selling that's pretty much an OpenStack appliance. And in development of this product, we actually went in the first version of the product with a standard Neutron implementation, which pretty much means single node Neutron implementation. And in the 1.1 release of the product, we actually switched this to Neutron DVR. And the complete presentation is not about the product. This is the only time you will see the name. The presentation is about what actually happens and what are the differences that we saw working with Neutron and how this actually influenced the performance of the complete appliance. I will say now very specific, we are good at developing OpenStack products and so on. We are probably not the best company to do performance analysis. So all of the measurements you see in the presentation are our internal measurements that we did. They might be a little bit not completely precise, but they will give you a kind of a good direction. We are actually working now with external company that will do official measurements and so on. So take this with a little bit reserve, but you have a lot of reserve here. A little bit about myself. I'm a product manager actually of this product, or one of the product managers. And I've worked as a product manager and evangelist with several companies over a quite long time. Worked with several open source projects. Was actually in the team that developed the first Eclipse pod. So if you remember the Eclipse environment, one of the big open source projects. So here is the starting point. And when I say the starting point is basically, this is what we did in the version 1.0 in the product. So you have kind of a base from which we will compare then the next version and the next development. We developed OpenStack basic configuration, and just to give you a feeling, this is a hardware configuration with complete spine leaf networking, so it includes networking. It includes management nodes, so there are 3 management nodes that actually pretty much run OpenStack and everything that's needed around OpenStack. And there are many compute nodes that are actually deployed now with NOAA Compute Service, with KVM and so on, that actually run the VMs at the end. The management nodes run a little bit more of the stuff because in a complete appliance, you have to take care of MNA, MNR, and so on, different layers. We solved in the basic configuration several problems. I will talk about one specifically, but basically, we solved the physical high availability of the networking in the basic configuration. So with a regular Neutron already. I will tell you exactly how we did this. We had in the first version complete Neutron-defined software-defined networking. So we used Neutron 100% in the complete appliance. There was nothing that wouldn't be using Neutron. We have keystone-based network separation, which pretty much means it's a multi-tenancy system, okay? You can run several tenants. Each of them will have completely separate network. So if you want two different projects pretty much to communicate, you will have to define a router between them. I said physical high availability at the beginning, software high availability of the networking. So pretty much software high availability. If you look at Neutron, Neutron actually uses one node in the regular one node configuration to run all of the networking around it. What software high availability means is what happens when this node goes down. So we have to reconfigure the software on the fly and pretty much get everything running as soon as possible. And this takes us really almost no time. And we solved this simplified updating between versions, which pretty much means you're running, this version was running kilo release of OpenStack. The version where we implemented DVR was running Mitaka release of OpenStack, and the updates for us from one to another version for us is a no-brainer. I mean, this is few hours of execution on the system. We actually deployed in the product Mitaka release about 7 weeks after Mitaka was officially released. And this is a product that is used by other customers. Okay, a little bit about the physical network configuration. I'm not going into companies here, but you see at the top, customer switches. They connect to the internal aggregation switches that aggregate several racks together. Those are 40 gigabit level 3 switches. Each rack has 10 gigabit level 3 switches as top of rack switches for the data network. We have a completely separate management network, so management network didn't play any role in the performance data here, okay? It runs completely separate. And each node is connected on the data network with 2 10 gigabit ports, which are bounded together. So we have, from the network perspective, from the physical network perspective, a lot of capacity here. I mean, top of rack switches are 1.92 terabit switches. To fill this switch, you really have to run something essential over them. But of course, the physical configuration was not a problem for us. All of the interfaces we have are bonded. We are running OSPF between them and so on. But basically what this means that from outside they look at like a single IP address, and we are actually using both ports and bond them together, which pretty much means every communication that we have to these nodes can use 2 times 10 gig, so 20 gig connection maximum, theoretically. This is how we implemented high availability. Basically what we have is here different platform nodes. Actually on 2 platform nodes, we are running absolutely identical Neutron implementation. The 3rd platform node is a tiebreaker. And then between those nodes, we have health checks. We are pretty much pinging the other node all of the time. We also have a synchronization of metadata between them, so they are always synchronized. One of those nodes is active. And when the node is active, it runs actually all of the Neutron communication over it. The 2nd node is waiting, doesn't do pretty much anything. Up to the moment when a failure occurs on the 1st node, and actually we are waiting a little bit, we actually need 3 pings before we switch over, just to prevent kind of busy node behavior and switching without a reason. But we are just flipping the IP between them. And that's all we are doing. So switch from active to passive for us is pretty much no time, because you can flip an IP between them very, very quickly. And by the way, on the implementation side, actually all of the OpenStack we are doing here runs inside of Docker containers. And this is one of the reasons why we can update very quickly also. But this is the problem that we solved already in the base configuration. The only reason I explain this is I will tell you what happens with this when we go beyond, beyond the simple implementation into DVR. On the logical networking, how everything works in the basic configuration is you have 3 nodes here. 3 nodes have different tenants, different VMs from different tenants connected to each other, and each tenant, just for the demonstration purposes, has 1 logical network. Of course, they could have more of them, but just here, 1 logical network. When you have to actually communicate between those logical networks, you have to go through the Neutron gateway, because this is the only place that does routing in the single node Neutron implementation. And if you go from those tenant networks out of the system or from outside into any of this VM, of course, you are once again going over the Neutron gateway. This was a substantial problem for us, okay? This was actually the trigger why we had to look into other technologies and pretty much said, you know, we cannot run a system that has 200 nodes and have this limitation in it. And we looked at different technologies at the beginning, but then decided very, very quickly that let's test DVR because it's kind of universal. We are not dependent on any specific switch implementation. The same picture a little bit in a different perspective. And this is just an explanation how it actually works. When you have a communication path between 2 VMs in the same tenant, it's very easy. You're in the same virtual network, you have direct communication, you don't need to do anything on the Neutron node, you don't go over the gateway, okay? When you are going between a VM, VMs in different tenants, so between 2 different logical networks, your communication actually goes from the node, goes to the Neutron management node, and then from the Neutron management node to another node, okay? So basically you have here a double network communication immediately. And all of this goes over 1 node because the Neutron management node is just 1. The worst case scenario is actually here between VMs and the public network. I mean, you're going from the VM, you're going to the gateway, and then you're going external, or from external, you're going over the gateway internal. So you once again have a lot of traffic here that you are causing just because you have this 1 gateway around. So this is kind of the limitation that we had in the version 1.0. This is the standard Neutron implementation. Now, if you never before looked at DVR, what DVR actually is just a special configuration and redistribution of different agents of Neutron. I mean, this is not a different software. You are using exactly the same software. It's a different configuration and different kind of deployment. And the difference basically is that at every compute node that you have, you are deploying the DVR component, the Neutron agent at the Open vSwitch. So you can do the switching directly on every node. Of course, all of them have to be synchronized, and all of them have to understand exactly what to switch. So this is a little bit of traffic that you have here in addition to the previous implementation. The other thing, of course, you have to have kind of the possibility to actually deploy this additional software on the compute nodes in some kind of automated way. But this is actually not a big problem because in either case, you are already deploying Nova here, and you before had a Neutron agent and things like this. So it's just work. You are deploying more stuff, but it's not a new science that you are doing here. On the management node, on the central, you still have a Neutron gateway. Here, it still stays on this management node. In addition to this, and I will explain in a moment why you are needing it there, it will still do some kind of a work, and of course in the configuration files there you will specify that you are using DVR. Not a big thing here. If you have the same situation now, 3 different private networks, and let's look at three different use cases. One, when you are assigning to VMs fixed IPs, and you are using SNet, you will still have to go through the Neutron single node gateway, okay? This is the limitation of DVR. DVR cannot do this kind of work. However, when you are using the floating IP, in whatever way, you can communicate directly to external network, and what's actually missing here, you can actually communicate directly between different nodes, between different compute nodes. So this is the big benefit that the DVR brings you compared to a single node implementation. A little bit of demonstration what's happening. Example 1, VM1, so on the cloud compute node 1, VM1 from network 1 communicates to something on the cloud compute node 2, which is VMware 4. So we have a communication actually between 2 VMs in the same network. It goes over the DVR interface bridge, over system switches, goes back on the other side, is straight communication. There is nothing that we would be doing with the Neutron gateway. Okay, it's completely dead at this time. There is no double communication anywhere. Another example. If we have a VM1 with floating IP to external network, and this communication is very straightforward, once again, network, DVR, bridge, public interface, system switches, external network. Once again, Neutron gateway didn't see this at all. And the last example I have here is how about if you have a fixed IP, and when you run this communication, you will run the communication exactly in the same way as before. From network via bridge, via system switches, to the Neutron gateway, through the bridge, and then whap, out again. So this communication will be exactly the same as before. You will have to make some kind of decision if you are giving a VM a fixed IP or a floating IP and so on, based on this, and because this will actually mean performance differences in your implementation or in your networking altogether. The high availability of networking. A little bit different picture here, but a little bit more detailed picture. But at the end, the high availability of networking is exactly the same. We basically did not touch this implementation in whatsoever way. Okay? It just worked. I will also say now, at this point in time, our implementation that we planned, remember, it's a product, you're doing it a little bit slower, you run a lot of tests. We planned this for 2 to 3 months. This was our development plan. After 2 days, the developer that was working on this called us and says, it's working. It's not working 100%, but it's working. And we looked at him like, you are completely crazy. This never happens. That's such a difference in time. So after 2 weeks, we actually had 100% working configuration and tested configuration on DVR, so from the previous version to the new version. It's not a big science to implement DVR. This is basically the statement I want to say here. Not a big science, it's just a little bit of work. Now let's go to performance. When we looked at performance, we actually created 2 separate but completely identical OpenStack implementations, and this is pretty much how we tested it. So we had 2 systems that were interconnected with 2 times 40 gig physical networking. Basically what we said, this 2 times 40 gigs should not be a bottleneck at any point in time in our tests. We used on each of those 4 compute nodes, each of them 16 cores, 256 gig, 2 times 10 gig networking adapters bonded, and separate management networking. And we had the 3 management nodes. We ran on those 4 nodes 30 VMs and connected them to 30 VMs on the other side. So basically 30 VMs in each OpenStack implementation and connected them. And those VMs were running nothing else but network traffic. So they didn't write to the disk, they didn't do any mumbo jumbo around this. It was just sending network traffic, receiving network traffic. We really wanted to do an exclusive test for networking. Before DVR performance, so version 1.0 of our product, the performance here was a little bit of limited. Actually, we saturated our Neutron node at about a little bit under 10 gigabits per second. Actually, to be precise, it was about 8.6 gigabits per second according to our measurement. Why is this? Because remember, whenever you are communicating with this node, you have at least double traffic on your network and on the node. So you are saturating this node very, very quickly. Now, what the slide is not saying, this node was actually running at about 80% of CPU capacity. It was running like crazy because it was processing all of the time this networking traffic. And the other nodes didn't do much. I mean, they just ran some VMs, and that was it. We remembered exactly, so we measured not just the performance of the networking, but the load on different nodes. And I don't know exactly what the number was, but on the compute nodes, the load was pretty much linear, okay, all of the time. Remember, 4 compute nodes. With 4 compute nodes, and we had floating IPs for communication here, so not fixed IPs. We saturated the networking at more than 60 gigabits per second. You have a theoretical maximum speed of 80 gigabits per second with those 4 nodes. We actually came very close to 65. It was 64 point something. And what this basically means is that each node was pretty much independently working on the highest possible speed it could. And nothing was slowing it down. We actually did a test later on and increased the number of nodes. And it was scaling almost linearly. We were like at 98% of linear scaling, which is amazing. The other thing that happened is the CPU load on the management node pretty much didn't exist anymore. So management node didn't do almost anything. I mean, just a regular metadata synchronization from time to time. But more important, we actually measured what the change of the CPU load was on compute nodes. And it was barely seen. It was about 2% more CPU load on each of the compute nodes that we had with DVR. So we quickly decided this is now the default implementation we have here. I mean, if you buy our solution, you will get DVR implementation for Neutron. You don't even have the possibility to configure anything else. It's just there. It just works. We also did the test, by the way, with SNAT. It was exactly the same performance as before. Okay, we topped it about 8.6 gigahertz. Gigabits per second, and because it goes through the same one node. So this is kind of the performance testing we did. And what this basically means in the conclusion is when we are looking at the DVR implementation, substantial, I mean, there are worlds between the network throughput that you have without DVR and with DVR. And the other thing that I didn't say this, we actually run this on two completely different types of switches, okay? And the reality is, this doesn't have any influence on switches. You can use whatever you want. You don't need to do any special configuration. You don't need to have any special type of a switch, nothing. You just have to open the ports for routing. If you locked it down because of security before, just the Neutron nodes, you have to now open it to all of the compute nodes. But that's it. We run this actually, if you need to know on Arista and on Cisco, we actually physically run the system, pulled our Arista switches, put in Cisco switches, and it worked. No change whatsoever. If you have any serious OpenStack implementation, you will have to do something like DVR. And we strongly recommend it. It's just, you don't want to have 100-node implementation that would be stopped by a single node, a Neutron implementation. You can make the node really, really big, but at some point you will always reach the limit. And the cost of implementation, yes, it's there, but it's relatively small. I mean, 2 weeks of implementation to do this in a product, which means about 1 week in an average project, because you are not running 900 tests on this like we do. This is not a big cost. And from the architecture perspective, it's really not a big difference. You are deploying a little bit more software on the nodes. Yes, you're using about 2% of processing power on compute nodes, but you are gaining factors of speed. So we actually did this, and this is another demonstration of how stable OpenStack is now compared to previous years. We are doing this change from not DVR single node implementation to DVR implementation as a software update on customer systems. And this is not a big magic. It works, okay? We are just shutting one node down and updating it to the next version, and so on, and so on, and so on. Changing the management nodes, so updating the management nodes and updating the metadata information, and that's it. And because we are doing this in Dockers, it actually works very, very quickly and very reliable. Well, that's pretty much what I had here. I didn't want to hold you too long. I'm open to any questions, or if you have more questions about other stuff, anytime. I also have the business cards here. I know we are shutting down here, so if you want to communicate with me later, it's also okay. Please. Let me show you this. So basically, oops, I will come to the right slide. Basically what you are saying, okay, if you have just one flat network across everything, you don't have more networks.
We run ourselves, no tenants, no serving to others, and still we need solution. I think you don't need that DVR setup.
Okay, let me go to the next slide. This will not hit you, okay? You don't have this problem. You still have this problem. If your VMs have to communicate externally, they will still have to go to this gateway. So all of the VMs you have on the network will go over one node, and this one will stop how much traffic you can do here. Okay, this is the problem that you will have if you scale up your network. Sorry, scale up the number of VMs. Okay. Any other questions? Yes, sir. Sorry, flat networking without gateway. If you define it just external, yes, but then you are not going over the gateway, yeah. But do you do this? I mean, sorry, from my perspective as a product, we cannot afford to do this. If you do this implementation in your project, yeah, you will not run into this. Okay, other questions? Then thank you very much, and hope you have a good last presentation, a closing presentation, and a good weekend.